Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Let's say you're trying to solve a limit. You substitute in the number, and you get 0 over 0. In algebra, we try to factor or conjugate our way out. But what if the function is something like sin x over x, or e to the x minus 1 over x? You can't factor those. Enter L'Hopital's rule. It's the ultimate cheat code that uses derivatives to solve the mystery of indeterminate forms. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. First, we need to define what an indeterminate form is. It is a limit result that doesn't have a defined value. And this includes things like 0 divided by 0, or infinity divided by infinity. Now, there are many other types as well, things like 0 times infinity, or infinity minus infinity, or 0 to the power of 0. Now, for L'Hopital's rule, we're only going to be focusing on the first one and the second one. So 0 over 0, or infinity over infinity. And what this rule allows us to do is that if the limit ends up being 0 over 0, or infinity over infinity, then the limit as x approaches c for f of x over g of x is equal to the limit as x approaches c for f prime of x over g prime of x. So in other words, we can take the derivative of the top and the bottom separately and then apply the limit. And the important thing to remember here is that this is not the quotient rule. So remember how before we talked about the quotient rule, which was when we take the derivative of a function and it's a quotient, it's f prime times g minus f times g prime over g squared. But here, we're not trying to take the derivative of the quotient f of x over g of x. We're just trying to find the limit. And we're taking the derivative of the top and the bottom separately. So let's take a look at how we actually use this. For the first example, we want to take the limit as x approaches 0 for sine of 5x over x. So notice that if we try to substitute in 0, our numerator is going to be sine of 0, which is 0, and then our denominator is also 0. So right now, we have our indeterminate form of 0 over 0, which means we can go ahead and use L'Hopital's rule. So then by applying L'Hopital's rule, we are going to take the derivative of sine 5x, and that is going to be equal to 5 times cosine of 5x. And this is going to be over, and we're going to now take the derivative of x, and the derivative of x is just 1. So this is the limit as x approaches 0 for this new fraction. And now we're going to attempt to do our substitution again. So if we substitute in 0, our numerator is going to be 5 times cosine of 0, which is 5. And our denominator here is just 1. So we no longer have our indeterminate form, and we no longer run into trouble when we try to substitute in the number. So therefore, this limit is equal to 5 over 1, which is equal to 5. For our next example, we're trying to take the limit as x approaches infinity for ln of x over x. So again, if we attempt to substitute this in, we end up with the indeterminate form of infinity over infinity, which again tells us that we can now apply L'Hopital's rule. So this is equal to the limit as x approaches infinity of the derivative of ln of x is 1 over x, and then the derivative of x is just 1. And now we no longer have an issue because our denominator is 1. So if we attempt to do a direct substitution here, this ends up being 0 over 1. So therefore, our answer here is equal to 0. In our next example, we're going to show that sometimes applying L'Hopital's rule just once is not enough. We might need to do it multiple times. But before we do that, we first need to check that it's in one of the acceptable indeterminate forms. So if we substitute in 0, we get this as 1 minus 0 minus 1. So our numerator is 0, and then our denominator is also 0. So this is in the form of 0 over 0. Therefore, we can apply L'Hopital's rule, and we get this is equal to the limit as x approaches 0 of taking the derivative of the top is going to give us e to the x minus 1. And then the derivative of the bottom is going to be 2x. Now notice that if we try to substitute in 0, we're going to get a numerator that is equal to 0, because e to the 0 minus 1 is equal to 0. And then our denominator here is again still 0. So we still have an indeterminate form of 0 over 0. And that is okay, because all we need to do is apply L'Hopital's rule again. So if we do that, we get this is the limit as x approaches 0 of, now if we take the derivative of our numerator, we get e to the x. And if we take the derivative of the denominator, we get 2. And now we no longer have an indeterminate form, because if we substitute in 0, we get e to the 0 is equal to 1. And our denominator is 2, so therefore our final answer here is 1/2. For our fourth example, we're going to take a look at what happens when we get an indeterminate form, but it's not one of the acceptable ones. Here we can see that if we try to substitute in x is equal to 0, we get this is in the form of 0 times negative infinity. But in order for us to use L'Hopital's rule, it has to be either in the form of 0 over 0 or infinity over infinity. Which means before we can apply L'Hopital's rule here, we need to first get it into one of those forms. And to do that, we just need to rewrite this as a ratio. So this is equal to the limit as x approaches 0 from the right-hand side of, so instead of going x times ln of x, we can rewrite x as 1 over x. Well, why do we want to do that? Because if we write this as 1 over x, this now can be rewritten as a quotient. So this is the limit as x approaches 0 from the right-hand side of ln of x over 1 over x. And now notice that if we try to substitute in 0, we get that this is in the form of infinity over infinity. So therefore, we can go ahead and apply L'Hopital's rule. And we get this is equal to the limit as x approaches 0 from the positive side of the derivative of ln of x is 1 over x, and the derivative of 1 over x is negative 1 over x squared. Simplifying this a little bit is going to give us this is the limit as x approaches 0 from the right-hand side of negative x. So now we can go ahead and substitute in 0, and we get a final answer of 0. And let's just take a look at one more example where we need to do some algebraic manipulations first. So here, if we try to substitute in 1, we see that this is in the form of infinity minus infinity. Which means the first thing we need to do is to rewrite this expression into one of the acceptable forms. And the way to do that is going to be using a common denominator. So we get limit as x approaches 1 from the right-hand side of x minus 1 minus ln of x over our common denominator, which is ln of x times x minus 1. And then just to check, if we try to substitute in 1, right now this is in the form of 0 over 0. This means we can now go ahead and take L'Hopital's rule, and we get limit as x approaches 1 from the right-hand side of the derivative of the numerator is going to be 1 minus 1 over x, and then the derivative of the denominator, we're going to have to use a product rule here. So this is 1 over x times x minus 1 plus ln of x. So here we can see that if we attempt to substitute in 1, this is still in the form of 0 over 0. And you're welcome to apply L'Hopital's rule again immediately, or we can attempt to simplify this a little bit to make our lives a little bit easier. So simplifying is going to give us this is equal to the limit as x approaches 1 from the right-hand side of, we're going to put our numerator over a common denominator. So this is going to be x minus 1 over x. And then we're going to put our denominator also over a common denominator. So this is going to be x minus 1 plus x times ln of x over x. And now we can cancel out the over x on the top and the bottom. So this simplifies to the limit as x approaches 1 from the right-hand side of x minus 1 over x minus 1 plus x times ln of x. And just to double check, we can try to substitute in 1, and we can see that this is still in the form of 0 over 0, which means we can apply L'Hopital's rule a second time. And once we do that, we're going to get this is equal to 1 over 1 plus, applying the product rule to x ln of x is going to give us ln of x plus 1. And now if we try to substitute in x is equal to 1, we get this is equal to 1 over 2. And that would be our final answer. And now let's do a quick recap of what we covered in this video. We learned that in order for us to use L'Hopital's rule, we need to always substitute in the value to ensure that it's actually indeterminate before we can use the rule. And the only two forms that are accepted are 0 over 0 and infinity over infinity, which means if we get any other indeterminate forms, we must perform some algebraic manipulation first before we can apply L'Hopital's rule. And lastly, we saw that sometimes applying the rule once isn't enough. If you get an indeterminate form again, you can apply the rule a second or a third time, but just make sure that it's in the form of 0 over 0 or infinity over infinity. And we're going to explore some of those other indeterminate forms in the next video. And now it is your turn to give this a try. Can you determine the limits on the screen here? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.